This part will cover the final system of this series, which is pathfinding. So pathfinding will be required for most movable sprites in this type of game, and in this part I'm going to create a basic worker class that will have an update method and also a pathfinding system. We're going to be using the pathfinding package and more or less implementing the basic example included in its pip page, which I'll put a link for in the description. The first thing we have to do to implement a pathfinding system using the pathfinding package is to define our collision matrix. This will be a matrix just defining which elements are passable, which elements are blocked, and you can even impose certain weights, making it more difficult to pass through certain elements. So that's what we'll be doing now. We will include this collision matrix in our world class. And we're going to define a method for creating this collision matrix, because we already have a lot of this information already in the world class. If you remember going down to where we defined our elements, the dictionaries, we have this element called collision. Basically letting the game know which tile contains an object and which tile doesn't. So we can more or less just repackage this and turn it into a matrix of ones and zeros. So below this method, I'm going to create a new method called create collision matrix. So define create collision matrix. And in the pathfinding package in Python, the way you define a passable tile is to use the number 1, whereas if it's impassable, if there should be a collision, then we're going to use 0. So we're going to start off by creating a new 2D array, and we're going to initialize all the elements as 1. So everything is passable at the start. So we can do for x in range self.grid length x, and then repeat this in the y. Okay. Now what we're going to do is we're going to iterate through all of the x and y grid values. We're going to query whether the tile contains a collision or not, and if it does, we're going to assign a 0 in that x and y position. So we can say for x, again in .x grid length x, and then same in the y. And then we're going to say if self.world x y, so extracting that xy element and taking the collision. So if it's true, we're going to assign a 0 in that position to the collision matrix. Okay, so this is something really important to know, is because of the implementation of the pathfinding package, the matrix, this collision matrix, needs to be inverted. So instead of doing x and y, we're going to do y and x, and that's just really important to know. We're going to set that as 0, and now we can just return this collision matrix. Okay, so then going up to our init method, we can include this below self.world, because we need the world to be defined first, and we can say self.collision matrix equals self.create collision matrix. The final thing for us to do to finish off this collision matrix is every time we build a building, we will also need to update it. So if we go into our update method and go to the section where we create buildings, we need to add another line here, and it's going to be self.collision matrix, basically doing the same as this but for the collision matrix, which will be used for the pathfinding. Again, the only difference, or the biggest difference, will be that we need to invert the x and the y's. So we need to switch these around, and then we can say equals 0 in that position. Now that we have our collision matrix defined, we can start creating these workers and the worker class. So before I move into creating the worker class, I just want to give a new variable in the world, and it's going to be very similar to the self.buildings. We want the workers also to be defined in a kind of two-dimensional array, because that will help us when we need to draw these workers in the correct render ordering. So I'm going to literally copy and paste the self.buildings and just define it as self.workers. Okay, having done that, we can start building this worker class. So going to our game folder, creating a new script. I'm going to call this workers.py, and we'll start off by importing all of the functions that we need. We're going to take pygame as normal, as PG. Going to import random, because we'll use this initially. And now we can start importing the pathfinding functions. For those that looked at the pip page, you can just tell that I'm taking exactly what they've gave in the example. So we're going to take diagonal movement. We're also going to take the grid. And finally, we need to import which finder algorithm we want to use. And in this tutorial, we're going to use the A* finder. So from pathfinding.finder A*, and we're looking for the A* finder. Good. We can define our worker class, and inside the init, we want to pass it which tile is this worker going to be created on, is going to spawn on, and also the world, because the world holds really useful information like the collision matrix, which we'll need, which the worker will need to know when it's doing its pathfinding. So we can start storing these things inside the class. So self.world equals world. The worker will have an update method, so we want a way to update it, and inside world we made this entities list, which gets updated in the game loop, so we can just append this class there. Now for the image of the worker, I couldn't find a good isometric character to freely include and distribute, so I've actually put in one of my own creations from a different game, and everyone's free to use it as they like. I just wanted some character placeholder. So and you'll be able to find that in the GitHub repository. So to load in this image, we're going to do our usual pygame.image.load. We're going in assets, graphics, and it's worker.png. I'm just going to convert alpha. We're going to give this class a name to specify that this is a worker. This image is also a little bit smaller than the other tiles, so we're going to scale it up a little bit. So we can do self.image equals pygame.transform.scale. We're going to take the image, and then for the width and the height, we're going to extract the get width, and multiply it by 2, and then do the same for the height. So get height and multiply it by 2. We're going to specify that the tile of this worker is equal to the tile that we initialized it as. Then we're going to start defining some of the pathfinding specific variables. So I'm just going to put pathfinding here. Firstly, we want to say to the world which tile is this worker placed on. So we can do self.world.workers, and then from tile we can extract the grid element. So this will be the X grid element, and then we want to also take the Y grid element, and we can say on this X and Y tile is this worker. And we also want a movement timer, so after every X seconds or whatever, the worker will change tiles. So you can also define this move timer with pygame.getTicks. And the first method we're going to create for this worker is a method called Createpath, and this will define, basically the path that the worker will follow using pathfinding to move around the world. So we can define this as Createpath, and we're going to define a variable called searching for path equals true, and then we can say while searching for path. At the beginning, we're just going to have these workers just randomly move across the world with no kind of specific destination. So we're going to pick random tiles. If there's no kind of collision on that tile, then that is a valid kind of destination for this worker, and the worker will create a path to that tile. So we can say x equals random dot rand int, going from 0 to self.world dot grid length x minus 1, and same for the y, just replacing that with y. And then we can define this destination tile is self.world dot world the x and the y position, and we can query whether this destination tile contains a collision or not. If it doesn't, then it's a valid destination. So we can say if not dest tile collision. And now now that we found a valid destination tile, we can start building up the path for this worker to follow. So first thing we need to do is to define the grid, and we're going to use that grid class from the pathfinding package, and we're going to specify that the matrix of the grid is the collision matrix that we defined inside of the world class. So like that. We need to, now within this grid, we need to define the start position and the end position. Now for the start position, it's going to be the current position of the worker, and we use the self.grid.node for this, and we need to pass it an x and a y position. So the x position is going to be the self.tile grid and the x element, and then the same thing for the y, but the y position, which is 1. For the end, we can just say self.grid.node, and we're going to use these randomly generated x and y's, because we also know that these x and y's are a valid destination. Now that we've defined our grid and start and end, we can define our finder. So how would we like to find the path? So you can use this a star finder class, and in here the only parameter that I'm going to say is the diagonal movement, and there's a special kind of way of defining this, and I'm going to say never. So I always want the worker to move either like 1 up in the x or y direction or 1 down in the x or y direction, not x and y at the same time. So we're going to define this as never. We're going to say the path index, so how far along the path are we? We're going to just initialize this as 0. And now we're going to generate the path. So we can say self.path, runs. We can use the finder that we defined. We can use find path, and here we need to pass it a start, end, and grid. So we're just going to pass it what we've just defined. So self.start, self.end, and self.grid. And now this should all have worked well when we've found a valid path for our worker to follow. So we can now define this searching for path equals false, which will break us out of the while loop. So now that we have a way to create our path, we can use that method in the init. So self.createPath, and we can start to create our update method. So down here, I'm going to create our update method. I'm going to first create a now timer, so just pygame.getTicks again, and we want to say if now minus self.move timer is greater than a second, so 1000 milliseconds, we want to move. So I'm going to say new position equals self.path that has been defined from Createpath, and we want to extract the path index, so which we initialized as 0. So we're going to, at the start, we're going to just take this first element of self.path. Now we need to update position in the world, and we're going to create a new method for this. So I'm going to call this method changeTile, so changing the world tile that the worker is on, and we're going to say which tile we're going to move to. So the first thing we want to do is to remove our current position from the world, because we're moving away from that tile. So self.world.workers, and we want the X and Y grid positions, so like this. And we're going to set that back to none, which was the default state. So that's removing our current position from the world, and now we want to add the new position that we're going to move to. So I'm going to copy this, and I'm going to replace this self.tile grid with new tile, because these are the X and Y positions of the new tile. And then we're going to set this again to self. And we also need to update now what is our new tile, and we can extract that from the world. So self.tile equals self.world.world, and we're going to be taking these new tile positions, just like that. So now in our update method, we can use this method, so self.changeTile, and we're going to supply the new position, which is going to be the new tile. We need to update the path index. So the next time we move, it's going to be the next position, next element in the path. We need to reset the move timer, and we can reset it to setting it to whatever the timer is now. And we also need some logic that if we have arrived at the end of the path, then we need to create a new path. So if self.pathIndex is equal to the length self.path -1, then generate a new path. So we've finished defining our workers, and because we added our workers to the entities list, we know that they will be updated, but we still need a way of drawing them. And to do this, we're going to go back into the world class. We're going to go down to our draw method, and it's going to act almost exactly the same as the buildings. So we can copy and paste this down here, which is going to say draw workers, and we're going to change some of these values. So worker equals self.workers. If worker is not none, we want to draw the worker image, which is contained within the worker class, and replace this with worker as well. And that should be all we need. Now that we've defined how the world will draw our workers, we can start adding some to the game, and hopefully see them move around the world, not passing over the rock or tree tiles. So let's go into the main game class. We can import the worker class, and just below where we create our world, I'm just going to create 10 random workers which should just randomly move around the world. So we need worker, /in, and what do we need? We need the starting tile, so I'm just going to put this in the middle of the map, and we need to pass it the world. So now when we run our game, what we should see is our little workers spawning at the center of the map, and hopefully, and the rendering looks good, they're hidden behind the trees and rocks, but they shouldn't ever walk across those tiles, and they don't seem to be. So yeah, this seems to have worked well. Yeah,